We're going to say this is 1.2 day one. We're going to do, we have 1.2 kind of broken up into two sections. Depending on where we flip, you may need to start on the next one. The next one starts at the increasing, decreasing. So we'll call this 1.2 day one. Review from Algebra 1 and Algebra 2 should be f of x. We read that as f of x. It's not f times x. This is function notation. You can do, the most common ones are f of x and g of x. How come? I don't know. H of x, and you can do anything like that. You can do v of t, very common in science, physics, velocity at time t, and we'll be using some of that throughout the entirety of pre-calc. So remember function notation. So I like this better because it shows you the ordered pair. F of x is equal to 5x squared plus 2. And if I want, instead of f of x, I want f of 3. I replace all of the x's with a 3, and then I do the math. And we do the math, and we get f of 3 is equal to 47. That means 347 is going to be a solution to this function, or to that equation, which is in function notation. Function and domain and range. Function, we're going to have a rule that assigns every element in the domain to a unique element in the range. Okay. The main thing is the domain is the set of all x's. We saw that in Algebra 2 as well. The range is the set of all y's. So the input is the domain, it's what you put in. The output is the range, it's what you get. So if you remember back to that previous slide that I think it looked like that, if I remember correctly. And then we put in f of 3 and got 47. A 3 is a member of the domain. It's the input value. We put that in for the x, and we got this out. That's the y value, or the range value. Okay, so again, review from Algebra 2. When we map things, it's very easy to see when you have a mapping, because what you're really looking for, if something is a function, each of its x values, okay, can only have one partner in the y's. So when we say not a function over here, it's because of this guy, okay? This guy can't dance with both y1 and y3 at the same time. You're not allowed to have two of the same domain values or x values be partnered with different y values. You can have it go the other direction. X3 can be partnered with Y3, and X4 can be partnered with Y4. So when you see it on a mapping, you're basically looking for, if I got more than one line coming out of the same X value, it's going to fail. Which leads us to, what does it look like on a graph if you talk about an X coordinate and a Y coordinate? Then we're talking about all of these X values going along here have their very own Y values. Now it looks like, Y is 0 there and Y is 0 there, but remember that doesn't matter. So this is a yes. Same thing here, even though it's choppy, all those X values only have one Y value. And then you don't have to go very far here where we say, how can 0 have 3 different partners? And that makes it no, it's not a function. So this one is not, and we can see that. And if you remember back to Algebra 2, you remember the vertical line test. So what we can do is we can run a vertical line through here. Let's see. And if we run our vertical line from the left to the right, remember what the vertical line test says is if I touch at any time, if I run a vertical line and I touch more than one point, then it fails. So you're going through here, and then you go through here, and it's like, boom, failure, big time failure. Boom, failure. If I touch more than one spot, because the vertical line is really the same x values. So when it says a graph is a set of points, every y function, It defines y as a function of f and only if no vertical line intersects the graph in more than one point, because those vertical lines are the x values. X equals a number is the vertical line, and that's why we can run that test going vertically. Find the domain of the function, use interval notation. We have started you on interval notation in Algebra 2 with trig because we use it extensively in pre-calc and then in calculus. So there is a rhyme and a reason to everything that we have done to this point. It's very important that you understand when determining domain, that is, what can the x's be? So this is the input or the x values. So when we're talking about the domain, we're talking about x values. These are the rules. You can't take the square root of a negative, so underneath the radical, and you can't divide by 0. Commandment number 1, thou shalt not divide by 0. Everything else is okay. So every time you're asked for the domain, you are looking for radicals and you are looking for denominators. I see a radical here. What we do is we say, if this can't be negative, that means, if that can't be negative, that means we take whatever is underneath there and we say it needs to be positive, or it needs to be not negative, which means it's greater than or equal to 0. And now we solve the simple equation. X is greater than or equal to negative 2. That's my domain. So if I did it in set builder notation, I would say the set of all x's such that x is greater than or negative 2, but we are more concerned with interval notation. If you think about the domain on a number line, my leftmost value is negative 2. It's filled in and we shade to the right. Remember, leftmost value is brackets because it's a filled in circle because it's equal to, and we go to the right forever. How far is forever? To positive infinity. Do you ever get to infinity? No. So positive infinity and negative infinity will always have a parenthesis. Okay, so remember interval notation. Let's take a look at these examples right here. Remember, domain. We're finding the domain. What are we looking for? We're looking for radicals and we're looking for fractions where we have something in the denominator. This has neither a radical nor a fraction, and therefore the domain is anything. How do we write anything in interval notation? Negative infinity, leftmost, positive infinity, rightmost. That's all real numbers. This is all real numbers written in interval notation. Next one, I've got both. I've got a radical and I've got a denominator. So what do we have to do? We have to take whatever's underneath the radical, which is x, has to be positive, non-negative. It can be 0. You can take the square root of a negative, or square root of 0, and I'm going to say x is going to be greater than or equal to 0 because I'm not allowed to put negatives in there. Now on the bottom, we're not allowed to divide by 0. What makes this 0? Well, if you really need to solve that, x minus 5 cannot be equal to 0. We should just be able to look at that and say x cannot be equal to 5. So now, number is greater than or equal to 0, but I can't be 5. So remember, interval notation. My leftmost value. So if I was going to graph this, I'd start at 0, got a 5, I go forever to the right, I'm filled in, I'm coming. Oh, I got to hop, I got to jump over that guy, go, and go there. So interval notation. Domain, leftmost value, 0, and I can be it, so I fill it in. I come in right, I'm coming, 5. I can go up to 5, but do not include the 5. Now I hop over the 5. Remember, that's a union. That means I'm going to join together, and I'm going to go right on the other side of the 5. And then I'm going to go forever to the right. So this is how you jump over an open circle. We're not allowed to be 5, so I'm 0 included all the way up to 5. Hop over the 5, start immediately on the other side of 5, and then continue forever. So this is like 4.9999999. Skip the 5, start at 5.000000001, something like that, okay? So try the bottom one on your own. Hit pause. I'm sure you all will. You should take a look at it, and then I'll solve it. Go. Okay, we're back. We take what's underneath the radical and say it has to be greater than or equal to 0. If you can do this without the little solving, that's fine. Take this, what makes the bottom 0? Take this, what makes the bottom 0? So I say, what is my leftmost value? My leftmost value is -7. This is -7 to the right, but I'm at -7. I'm coming up, -3, parenthesis, hop over the -3, go all the way to 4, parenthesis, hop over the 4, and go to infinity. Did I make it? I barely made it. That's a parenthesis out there. Okay, so we've got, now you can see where you're heading, where in 1-1 we started talking about factoring. Well, when we get to they get harder, right? They're going to start you with this as x squared minus x minus 12. And the first thing you're going to need to do is you're going to need to factor that. So we factor that, and then we can put together our domain and go from there, okay? So please, please, please understand, whenever they ask you for the domain, look for radicals. Whoa, 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 whoa. Look for radicals. Look for radical. What's going on here? We're all over the map. Whoa, whoa. And then look for denominators, okay? So we had over here, finding the range. Whenever we're looking for the range, we're going to graph it. You're either be given the graph or you're going to graph it on your calculator, but you might have to make some adjustments to your calculator in order to do that. Okay, so when we talk here, we already know, and like you still need to use some sense that I can tell here. Can't you tell? I can tell that x cannot be equal to 0. Like you can tell that. And if x isn't 0 for the denominator, for the domain, so the domain of this is -infinity to 0, 0 to infinity. If the domain if x can't be 0, there's no way I can get this y to be 0. So we can tell here that we're coming down like this. So when I talk about the range, I start with how low do I go? This goes down to the depths of hell, infinity, -infinity. And we come up to 0, union, and then we jump over and we're at 0 again, and then we go up to forever. So you can see we're following this asymptote here. Remember asymptotes? To approach but not to cross over, which is what they have down here. All real numbers except 0. Interval notation written like that. Good stuff. This is good stuff. Okay, increasing and decreasing, I think, starts on the day 2 video. So you can either jump on over to that one. If your teacher told you to continue on to that, you could do that. Otherwise, that will be the second half of it. Good work. Good work here today. Good